So this is Spencer's and Clayton's self-tuning guitar electronics project. The basic idea here is that by plucking this guitar string, all of the circuitry will analyze the signal and then physically tune the guitar accordingly to put it back into the right range. So the basic run through here is that this mic picks up the frequency off the guitar and comes into this circuitry. This is a diagram of our circuit, and it basically has three separate parts. This is the main inverting operational amplifier circuit we started with, and we've had to add these other additions to work it into the system. So the mic input comes in here through this voltage divider, and then this small capacitor gets rid of the DC offset so that the signal can then be amplified by this op-amp. And the output of that feeds into the digital multimeter, which ultimately feeds into LabVIEW. But after the signal is then output from LabVIEW, it comes out of the lab jack through a digital out, which then activates this LED, which indicates that the system is in tune. Here is our physical breadboard where the resistors have been chosen to give a signal gain of about 100, and that signal is outputted into the digital multimeter, which measures the frequency and takes it into the LabVIEW code. The LabVIEW block diagram takes in the frequency from the digital multimeter and then goes through a filter to get rid of the high noise signals that are sometimes picked up from the ambient noise in the room. And then once it's into that range, it goes into these two case structures. And these two true-false cases test if the frequency is in tune with the set value. The set value is a specific range that is input by the user, and if the guitar is not in that range, it'll either spin the motor backwards or forwards to put the guitar back into tune. But if the guitar is in fact in tune, it will turn on a visual LED indicator that is hooked in through the lab jack. And while all this is happening, the frequency is being monitored and picked up by this graph. So the visual interface for the setup is this slider, which sets the range which allows you to set the desired range, and this graph, which shows the frequency over time, so you can see how it changes as guitar becomes more in tune. The LabVIEW code has two different outputs. The first is this Lego motor jig, which is attached to the guitar head and physically spins the tuning knob to put the guitar back into tune. The other output is this LED, which is interfaced through the lab jack back into the circuitry, and this light turns on when the guitar is within the desired tuning range.
Okay, let's tune this guitar. Run the program. Clayton provides the strumming, and we see the motor start to turn and crank up the down-tuned guitar. And we can see the frequency going up. And once it reaches the correct tuning, the light should turn on and we'll be in business. And there it goes, guitar in tune.
We ran into many different problems while working on this project and had to learn a number of different troubleshooting techniques in order to overcome them. One of the difficulties we had was working with the physical nature of the guitar signal and trying to deal with all of the overtones and noise that was coming into our system. And even once we had a signal we could work with, trying to find a way to interface that with LabVIEW, we tried a number of different techniques, including timing chips and the oscilloscope, before we landed on the digital multimeter, which turned out to be the most accurate and had the highest sample rate of any of the interfacing tools we were using. We also had to learn a number of new LabVIEW coding techniques in order to only plot the frequencies without noise that have been filtered. And to do this, we had to tap into the case structure of the overall while loop so that when a noise signal came in, we could use a previous value that was in the select range instead of the new noise value, which caused our plots to go all over the place. Even with the numerous problems and hurdles we had to go through for this project, we're really happy with the way it turned out, and it's really cool to see the whole thing work as a cyclic process, and with the added bonus of actually doing a useful task of tuning a guitar.